Hello, I'm Paulina Chin of MapleSoft. In this webinar, we're going to look at how to color surfaces, lines, and sets of points using a variety of color schemes. The way we'll do this is to use the color scheme option, which was introduced in Maple 18. First of all, here is an example showing a surface with a default shading next to one with colors of our own choosing, which are all listed here: dark blue, light blue, purple, and yellow. This color scheme option is available with the plot and plot 3D commands, as well as with a number of other visualization commands that I'll talk about a little bit later. I'll be describing a few of the features of this option, but you can always get the full details from the plot color scheme help page. There are different kinds of color schemes available. The default is one that's called Z gradient, which is coloring according to the Z value. In the calling sequence that you see here, you provide a list with a Z gradient name, the list of colors, and any additional sub-options that you want. And here we produce a cone with the desired colors. If there are no sub-options, then you can use a shortcut and just apply the list of colors without specifying Z gradient. So here we get the same plot. Notice in this example that there are 3 colors and that they're distributed very evenly along the Z range of 0 to 10. The colors go from blue to green in the first half of the range, from 0 to 5, and then from blue to purple in the second half of the range. You can change the distribution of colors using the markers sub-option. So here, we have as many markers as we do colors. The first one is set to 0, the last one must be set to 1. And in this example, the middle marker is set at 0.1, which means the colors go from blue to green in the first 10% of the range, from 0 to 1, and then from green to purple in the remaining 90% of the range. You can also apply color schemes to curves and sets of points. Here is an example generated by the plot command. With curves, notice that the default coloring scheme is different. It's what we call the linear coloring scheme instead of the Z gradient one. This means that the color is not based on Z value or Y value in the case of 2D plots, but rather the colors change according to the order in which the points that make up the curve are stored. So in this case, the orange part is the first part of the curve generated, and it goes through red and eventually to navy blue. Here is the same curve using the Z gradient scheme. So first of all, because we're changing to a coloring scheme that's not the default, we have to use the longer form of the calling sequence. And notice the difference in the coloring. Now the orange points are the ones associated with the lowest Y values. Then we move up the Y range to get to navy blue. Here is an example using the point plot 3D command from the plots package. Notice that here too the linear color scheme is used by default as we run through the sequence of points from lime green to navy blue. Apart from the linear and Z gradient coloring schemes, you also have the ability to provide a custom coloring scheme. Doing so requires some Maple programming and understanding of the plot structures. I won't describe this process here, but you can see all the details on the plot color scheme help page. By default, the RGB color space is used. However, there are a number of other color spaces available, and these are all listed on the Color Tools Color Spaces help page. So observe these two examples showing the same surface. The first one uses the default RGB space and runs from blue to red. The second one also runs from blue to red, but it's executed in the HSV color space, and you can see the various hues that the surface goes through from blue to red. So we've seen examples of the color scheme option with the plot 3D, and point plot commands. This option is available with a number of other plotting commands as well, and I'll just give you a sampling below. So here is an example using the data plot command, which was added in Maple 2015. This next example uses the density plot command in the plots package. And finally, here is an example using the space curve command. Notice this example only uses one color in the color list. So Maple automatically computes lighter and darker shades in the range if you just provide one color. Now to end, I will give an example outside of the main plotting library, and you can see this on the signal processing examples help page. This shows various spectrograms that are done using the color scheme. In this one, white, light steel blue, and black are used. This one, white, light blue, red, and black. And a final example using steel blue, pale green, red, and black. This concludes our discussion of color schemes and plotting, and thank you for watching this webinar.